Hello students, today I am going to cover up next drilling algorithm, that is round robin. So round robin scheduling algorithm has some special features. A time quantum is allocated to the algorithm. For that time quantum, each process is allocated the processor. When the time quantum is over, the process must leave the processor, or we can say voluntary. The processor will be snatched from the dead process forcefully, not voluntary. So either the process can leave the processor voluntary. For example, a process has burst time 2 millisecond and processor is allocated a time quantum of the 4 millisecond. Since the after the 2 millisecond, the process will get over, it completes its execution, so it will voluntarily release the processor. Or suppose that if the processor has the time quantum allocated the time quantum of 2 millisecond and process has 10 millisecond to execute, then after 2 millisecond the processor will be snatched forcefully. So we will discuss the round robin scheduling algorithm here. The round robin scheduling algorithm is designed especially for the time sharing system. A small unit of time called time quantum or the time slice is defined. The ready queue is treated as a circular queue. To implement round robin scheduling, we again treat the ready queue as a FIFO queue of the process, and the new process are added at the tail of the ready queue. So it is the example. So when a process arrives in the ready queue, process P1 firstly allocated, then P2 will allocated, then P3 and then P4. Once its P1 has P1, firstly P1 will get the processor. Once its time slice, suppose at 2 seconds, 2 milliseconds get over, it will be inserted at the last of the queue, ready queue. Then after the processor is allocated to the P4 or P2, once the P2 get completed and still it requires a processor, it will be inserted at the last. So this is the process the round robin scheduling works. Advantage: it gives better performance in terms of average response time. It is best suitable for time sharing system, client server architecture and interactive system. Why for the interactive system? If a processor is waiting for the input or the resource it requires is busy somewhere else, for example, a printer is busy in the printing of the some job, so it will leave the processor, or we can say the processor will be snatched from that process forcefully, so that meanwhile another process can assign to the processor and it can perform its work. While in case of FCFS, if printer is busy, the process P1 will wait until the processor will not get the printer will not get released by the another process. Then after it will print, and then after it will release the processor. So average waiting time is too much in the FCFS while not in the round robin. It lead to starvation for the process with larger burst time, because processor will be allocated one after another. Firstly, for time slice consider as 2 millisecond. So P1 requires, if process P1 requires total 100 millisecond. So if time quantum is 1 millisecond, so process P1 will be switched over or enter into the ready queue for the 100 times. After 1 millisecond, another process will be there allocated to the processor. Then after another process to the processor, and then after P1 turns, then P1 again go to the ready queue. So this process will continue and it leads the starvation, not the deadlock. I am talking about the starvation. Means it has to wait for longer amount of time. The performance of heavily depends on the time quantum. Whatever the time quantum is taken. If time quantum I have taken 10 millisecond or 20 milliseconds, so it may works as a FCFS. A priority cannot be set for this algorithm because every process will get a chance after certain time of interval. Now, here is an example of round robin scheduling. Consider a time quantum as 2 millisecond or 2 unit of time, and there are 6 process P1, P2, P3, P4 and P5 and P6. The arrival time is also given, the burst time is also given. Now firstly draw the Gantt chart. How the Gantt chart will be drawn? I am designing myself. Now firstly at the time 0 there is only one process, that is your P1, that will execute for 2 milliseconds. 0 P1 for 2 milliseconds, and after that it has the remaining time as 2. Now at the 1 millisecond the process P2 arrives. The P2 will also execute for 2 milliseconds. P2, it is 4. Now P3. P3 arrives and it will get execute for 2 milliseconds. Here at the time there is a little bit confusion maybe there, or we can say just a minute. Yeah. After completion of the process, for example, P1 executes for a second, for 2 seconds to the processor, while the process P2 and P3 arrives in the ready queue. P2 and P3 arrives in the ready queue. Now, as 2 milliseconds over, P1 has not completed its execution. It still requires the processor. So it will be inserted at the back of the ready queue as we have already discussed. So here P3 arrives, process P4 arrives at the time 3 milliseconds. So P1 will be get inserted into the ready queue before the process P3 arrives. Okay. So P3, oh sorry, before the process P4 arrives. So here P1 will be inserted, then after P4 will be there. So this is the one of the important point that I want to discuss so that you will not get confused how P1 will get again the chance. Now in the ready queue there is a process P1. So P1 will execute for 2 milliseconds, that is 8, and then after P4 P4 will get executed for 2 milliseconds. uh, P4 requires only 1 second. So it will execute only for a second, that is 9. Now process P5 and P6 also arrived meanwhile, so process P5 will get execute for 2 milliseconds, then after process P2 will execute for 2 milliseconds, then after process P6 will execute. So this is the Gantt chart. Basic concept was here कि when the process P1 get completed its execution, but it still requires the processor. So how will it get inserted in the ready queue at the back? So this is the Gantt chart for the problem. Now, how can we calculate the waiting time and turnaround time? So as we have already discussed, the waiting time and turnaround time can be calculated individually for each process. Then after the average waiting time and average turnaround time can be calculated using the uh, turnaround time and waiting time for each individual process. So here for the process P1 gets completed at the 8 unit of time. So turnaround time is equal to, as we have discussed, turnaround time is the exit time or completion time minus arrival time. So for process P1, it is exit time is the 8 and arrival time is the 0. So 8 minus 0, 8. For process P2, P2 completes at 18 seconds and its arrival time is the 1. So it is 17. For process P3, the exit time is for process P3. For process P3, exit time is the 6 and arrival time is the 2. So it is 4. For the process P4, for the process P4, P4 exit as 9 and its arrival time is the 3. So 9 minus 3 is equal to 6. For process P5, P5 completes its execution at the 21 and arrives at the 4. So 21 minus 4 is equal to 17. And process P6, P6 completes its execution at the 19 unit of time and it arrives at the 6. So it is 13. Now, waiting time. Waiting time can be calculated as the turnaround time minus burst time. So turnaround time for the process P1 is the 8 and its burst time is also 4. So 4 minus 8 minus 4 is equal to 4. For process P2, turnaround time is the 17 and burst time is the 5. So it is 12. For process P3, turnaround time is the 4 and its burst time is the 2. So it is 4 minus 2 is equal to 2. For the process P4, turnaround time is the 6 and its burst time is the 1. So 6 minus 1, 5. For the process P5, turnaround time is the 15 minus burst time 6. So it is 11. For the process P6, turnaround time is the 13 minus burst time is equal to 3 or is 3. So 13 minus 3 is equal to 10. So this is the process how we can calculate the average, we can calculate the turnaround time and waiting time for each individual process. Now coming on the average turnaround time and average waiting time. So this can be calculated by the summing all individual turnaround time divided by the number of processes and summing of the uh, all individual waiting time divided by the number of processes. So this will be the answer. So this was all about the round robin scheduling from my side.